So we are going to finish the last one from last time, and then we're going to just do a whole bunch more practice together. So remember, you draw a picture if it's necessary. List out everything that you're given and your question mark. Everything is with respect to time. So d whatever dt for every single variable. Take a derivative. That's the most important part. That's the only step that's calculus. And then you're kind of plugging stuff in. So let me share my screen and show you this last one. So we did that one already. So this is the one, the plane is flying. And then there's a searchlight underneath that is rotating to follow it. And then it's gonna like go around the whole world and start over again. So real quick, look, what kind of triangle is it? It's a right triangle. Okay, so let's go back to our paper and go ahead and draw our right triangle. And this was our angle theta. Theta is changing, so it has to be labeled with a variable. Typically variables are theta. If you really want to like, no, I'm going to call it A, whatever, it's just letter of the alphabet. All right, and I'm going to have to keep going back and forth to get all the information from here. So it says that it is flying at an altitude of 4,000 feet. That's constant, that's not changing. So we can go ahead and put 4,000 on our triangle. If the altitude was changing, the plane would be doing this. Do you see what I'm saying? Like that doesn't happen. I get that it's going to change slightly, but essentially it's a constant altitude. If you want to talk about those slight changes in wind speed and friction, all of that, you can go over there to the science hallway because in here we're just going to do the math part of it, okay? Constant altitude. All right, now the plane is moving, so we have to label this with a variable. They called it x, so I'm going to call that x as well. And let me go ahead and put it back to where we want here. I'll pause it at, it's not a very big triangle, but I paused it at the 1,000 feet. So reading our little green box down here at the bottom, a plane altitude 4,000 feet, we got that, is flying west that way. Is anyone else directionally challenged? I'm like, I always have to draw a compass. At 700 feet per second. So how will I label that 700 feet per second on my paper? That's the plane going this way. Yes. Good. Now it's not 700. It is actually, why is it negative 700 feet per second? Yeah, this distance is becoming less and less. It's decreasing negative. Okay. So let me share again. I'm sorry, I have to keep going back and forth for you to be able to see it. A searchlight under it is tracking it. How fast? This is your question mark. How fast is the light pivoting? So what is our question mark? Well, the other variable is theta. So d theta dt is our question mark. And if you really wanted to call it y instead, valid, it's up to you. It's whatever letter of the alphabet. We just usually use theta for angles. Now, would you expect that to be positive or negative? As the plane's going by, this is what's happening to your angle. So negative. Do you see, do you get what I'm saying? Like how the angle is decreasing? So we're going to expect a negative result. Now everything's moving, so we have to pause at a certain moment. So it says when the plane is 1,000 feet. I'm going to actually change that so that we can do it without a calculator. So I'm going to change that part. I'm going to say when x is 3,000 feet instead of 1,000 so that I don't have to reach for a calculator. All right, now we need a relationship between the variables. It will not be Pythagorean theorem because we do not have the hypotenuse, and also you need to have the angle in there. So can you guys look at it and think about what the relationship would be? Sine is a very, very good guess. It's not going to be arc anything. It's either sine, cosine, or tangent, guys. You just need to remember your SOHCAHTOA from back in geometry. Why is it tangent? We have opposite and adjacent. Do you see that, TOA? Okay, opposite and adjacent. Here's the relationship. Tangent of theta equals x over 4,000. Or if you want to write that as 1/4000th x, like a coefficient, 1/4000th x, that's valid too. All right, now we're going to do a derivative. Do you remember what the derivative of tangent is? You're not allowed to forget. There we go. Secant squared theta. And it was theta, so what are we going to chain rule on? d theta dt. And if you're like, oh, I'm scared I'm going to forget that, you won't, because it's the thing you're looking for. Like if you've written everything out, you'll go, oh, I need to put that in there because it's the thing I'm trying to find. Equals. All right, derivative of 1/4000th x is 1/4000th dx dt. Every single variable gets a dt. All right, now we're ready to start plugging things in. Secant squared. This is, I would write it as blank squared. This is why I changed it from a 1000 to a 3000 so we could do this without needing to grab a calculator, okay? Just watch. I'm going to redraw the triangle. Here's our angle. If this is 4,000 and this is 3,000, what's the other side without doing any work? You should know though. Do you remember 3, 4, 5? It's just thousands, okay? Let me redraw it just as 3, 4, 5 though. This is getting messy here. Secant is the reciprocal of which trig function? Cosine. Cosine is adjacent over hypotenuse. 4/5. So secant is going to be 5/4. So over here, I'm going to put 5/4 in that blank that I left. Let me say that again. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. You just flip it. Okay. D theta dt is what we're looking for. Equals 1/4000th times what? Negative 700. Let's see how much we can simplify this without the calculator. If you square 5/4, that's going to be 25/16. Good. Now over here, 2 of the zeros are going to cancel. So we just have negative 7/40. And then to get rid of 25/16, you would multiply by 16/25. So let's see if we can reduce that down. 16 and 40 will both divide by 8. So that would reduce to 2, and then 40 divided by 8 is 5. So what would you have for the numerator? Yeah, negative 14. And then the denominator, 5 times 25, 125. Now, the units, but I just made us do it the whole way just in case it was multiple choice. You know, you have to simplify it the whole way. It's a good skill to have. The units for this one are actually very, very tricky because they aren't in the problem. You know how I always say, look back at the problem, don't make them up? We did a rate of change for an angle. Think about what mode your calculator always needs to be in. What mode are we always in? Radians. So when you're talking about an angle, it's going to be radians per whatever the time unit was. So was it seconds or hours or what was this? Second. Okay, so that's not going to change. Like, don't make that up. That's in the problem. But if you're talking about an angle, it has to be radians. So I love things like this because they're self-checking. If you get it to spell something, then you know that it's right. Now, it's only going to give you the consonants. Everything that's missing is a vowel, and then you'll be able to figure it out. I am going to go ahead and tell you 2 of the answers on the back don't get used. So I'm going to tell you which 2 they are. You're not going to use B. Oh, I'm sorry. Here you go. You're not going to use B, and you're not going to use V. So all the others match up with something. So I made it so that you can do process of elimination, like they will all link up with something. So I don't know how many of these I'm going to do for you, because I kind of want you to just use this time to be able to practice, but let's do at least 3 together, I would think. Okay. And let's just go ahead and start with the first one. So number 1, actually it's number 1 and number 2. Okay, so number 1. So you either your whiteboard marker or your piece of paper, whatever you want to use, and we'll work through some of these together. So a snowball is melting. What shape is a snowball? A sphere, right? So do you have sphere? Like, did you find that on your little formula sheet? Okay, so we're gonna need that. Snowball is melting at a rate of, and this is a big clue in the unit. See how it's feet cubed? How will we label this? It is a rate. It is dV dt. V for volume, And it needs a dt because it's a rate, something per something else. Also, it's not going to be 10. Why is it negative 10? It's melting. And you can put the units if you want, but there's not any units in the answers on these, so you can just put negative 10, that's fine. All right, at what rate? Here's your question mark. At what rate is the radius changing? So how will I label my question mark? dr dt is the question mark, and we will expect it to be negative because the snowball is shrinking. Now you have to pause at a certain moment. So when the snowball is 1 foot in radius, so when r is 1 foot. Now, which formula on your sheet are you gonna need? Yes, sphere volume. So do you see it on there? 4/3 pi r cubed. Yeah, I'm gonna take it. And if that one's worn out, throw it away. I'll go get more when we're at lunch. And now we're gonna do the derivative. So dv dt equals, and what would be that derivative? You're gonna do a power rule. Four, what happened to the threes? Yeah, they canceled. Pi r squared, good. Having to like pull teeth here, that's fine. Not done yet. What gets chained on? What's the thing you're looking for, guys? We already did dv dt. Guys, get with it. The derivative of r is what? dr dt. The derivative of v is dv dt. They're all just that letter with a dt, guys. Get with it. All right, now you can plug stuff in. Do I have dv dt? Negative 10 equals 4 pi, what's r? 1 squared dr dt. 1 squared is just 1, so you can kind of ignore that. Then what do you do to both sides? Divide by 4 pi. Now that's going to reduce. 10/4 would be -5. So -5 over 2 pi. The pi is in the denominator. Do you see that? So we divided that over. So go to your answers list and find -5 over 2 pi. What letter is it? G. All right, for 1, you can put G. All right. Stop that. You have to actually know how to do the math if you want to pass the test. All right. Number 2 is the exact same problem, except what did they change? Yeah, the radius is 2 feet. So you don't have to do any of this work again. You can jump straight to the derivative right here and plug everything in. What was dv dt? -10 equals 4 pi, this time 2 squared dr dt. 2 squared would be 4. Oh, the 4's cancel. That's kind of nice. And so what would your answer be? -10 over pi is your dr dt. So go find that on your answers list. What letter is -10 over pi? Or did we make a mistake? Oh, I can't. Yeah, I'm sorry. I canceled them out. They don't cancel at all. It would be 4 times 4. I'm sorry. So hold on 1 second. I'm sure you're right, but let me get us all there. I'm sorry. That's 16. I was like, oh, they canceled. They both came out to 4. No, 4 times 4 is 16. So yeah, -10 over 16 pi. So what would that be? -5 over 8 pi. Okay, is that on there? L. All right, so for number 2, you can put L, and I think there's a couple 2s up here. So sorry, I got all excited. They both came out to 4, and I was like, oh, they canceled. No, multiplying doesn't cancel. 4 times 4 is 16. My bad. I'm sorry. All right, let's do 3 and 4 go together. So we'll do this. Actually, maybe I'll do 3, 4, 5, and then I'll stop talking and just give you guys the time. All right, so 3 and 4 about a baseball diamond or baseball square, as we should say. So go ahead and draw your baseball square. Now, I guess you do need to know a little bit about baseball. Like, do you know where home is and first, second, third? Like, what order they go in? I guess you kind of, it's like prerequisite knowledge that you need there. All right, the sides are 90 feet. That's not changing. No one is picking up the bases and running around with them. They are staying put. Although I always bring up that I think that would make baseball a little bit more fun if the bases could move. Anyway, that's constant. All the sides are 90 feet. Since it's constant, you can label it with a number. The bases aren't moving, so those aren't changing. All right, Derek Jeter runs from first base to second base. Now you need to know which one's which. This is first and this is second. So he is somewhere in between. This is not to scale. I just put him somewhere in between first and second, and he's going that away. At a rate of 25 feet per second. Now I can't label that yet because I don't have any variables in my picture, so we'll have to come back to that. How fast is he moving away from home plate? So here's what you want to do. You want to connect him to home plate. So you need to connect him to home plate. Now, good. You want to focus on just this right triangle, and I need some variables. This side is 90. It's not changing. I'm going to call this side X and this side Y. Now I can go back and label some stuff because I have variables in the problem. So if he's running at 25 feet per second, how can I label that 25 feet per second? Good. And is it positive or negative? Good, because do you see how if he's running that way, this X distance is growing? 25. All right, what else do we know? Or what's our question mark, I guess? The next thing would be the how fast. dy dt is your question mark. Good, we're getting there. And you would expect it to be what? Positive. He's moving away. I mean, he's not running directly away from it, but if he's going this way, that distance is going to be lengthening. Now you have to pause at a certain moment. So go back and read. I can't fit all this up here at the same time. You have to pause at a certain moment. It says when he is how far from first base? 30 feet. So that's when X is 30. Cool. Now we need a relationship between all the variables, and it's going to be what? Bless you. Good. It would be 90 squared plus X squared equals Y squared. And then you do the derivative. 90 squared is... Why is it 0? Because it's constant. They're not no one's moving the bases. All right. All right. And derivative of X squared. 2x dx. There, that one went good. Equals 2y dy dt. And then I told you that it's a good idea to just go ahead and cancel the 2's. Just keep your numbers smaller. All right. And then you plug in. After you do the derivative, that's the calculus. That's the only step that's the calculus. Bless you. So what's X? 30 dx dt 25. Y we do not have, so hold on. And then dy dt is what we're looking for. This happens often that you'll be missing something. When you're missing something, where do you go? Good, perfect. Back to the original one and plug in what you have. So it's like a side problem. This is like a margin problem over here. It would be, I'm just going to write above it. It would be 90 squared plus 30 squared equals Y squared. 90 squared would be, yeah, 8,100. 30 squared would be 900. 9,000. Square root of 9,000 is 300. Well, the square root of 9 is 3. Did we do that right in our heads, though? I don't know. My brain did something weird, and now I'm like, I think it's 300. No, that would be 90,000. You're right. So it's going to have to be 30. Too many zeros. I was like, wait, hold on a second. That does actually sound like really, really large. Oh, and actually that's kind of cool because what'll happen to the 30s? Yeah, they'll cancel. So just 25. Is that an answer choice? Or did we mess up? Yeah, something doesn't feel right.
So you had 36 on the left side.
I can't square root 9,000 is what's going on. Okay, it's not a perfect square. I'm sorry. I felt like it. I'm sorry. That's my bad, guys. I don't, my blood sugar is too low right now. I felt like 9,000 should be a perfect square. I'm sorry. I just really, really wanted it to be. So this is 30 times 25 equal. I guess we'll just leave it as square root of 9,000. dy dt. So 30 times 25 would be. Yeah. I'm gonna just believe you. Because my brain is not, yeah, because 25 times that. Okay, and then, well, you can split this. It would be square root of 9 and square root of 1,000. Do you guys remember that from algebra 2? Splitting up roots? Because we're gonna have to simplify this to find the answer choice over there. So that'd be 3 square root of 1,000. And so when you divide that over 750 divided by 3 over square root of 1,000, is that a choice? Or does 1,000 split as well? I feel like, yeah, I feel like 10 and a, yeah, so 1,000, geez Louise. So 1,000 is gonna be 10 and 100. So this would be like 10 square root of 10. No, it'd be 25 over square root of 10, is that? Oh, then they rationalized it. Yeah, it's gonna be P, because then they rationalized it. So it would be 25 square root of 10 over 10. They just simplified it literally the entire way down. So 5 square root of 10 over 2. P, as in popsicle. All right, so 3 is P. Oh, there's another 3 though. There's a couple 3s. All right, 4 goes along with that one. So we're not gonna have to redo like the work. They're just gonna give us a different number to plug in. How fast is he moving away when he is 45 feet from first base? I'm gonna just use a calculator for this one instead of trying to do that in my head. I learned my lesson there. So here's what our derivative was. It had 2's in it, but I just canceled them out. So they changed the X instead of 30, they changed it to 45. But he was still running at the same speed. So what was his rate? Was it 25? I'm gonna just use a calculator. I'm not gonna mess around with this one. But again, you're missing Y. So you have to go back to the original relationship and do a margin problem. It was 90 squared, but they changed it this time to 45 squared. I'm just using a calculator. We're not playing around here because that was a complete disaster. So that's 1,125. I'm sure that's not a perfect square, is it? No. It's, oh, I'm sorry, it's 10,125. 10125. That is not a perfect square. Yeah, we're gonna allow a calculator for this. 45 times 25 is 1,125 over. I'm trying to think how this will split because they're gonna make us reduce it. I know, but there's one that's bigger. It's not 625. That's what I just tried. Let me see if it's two. Oh, it's. Oh, did someone just say 2025? Genius over there. So the square root of 2025, in case you didn't know, is 45. And so it's 25 over square root of 5, but I guarantee they rationalized that. So 25 square root of 5 over 5, which should just be 5 square root of 5. Is that a choice? Please tell me. It is. What number or what letter is it? D, as in dingo. All right, so 4 is D. Okay, good. I'm glad we did that one together. We'll do one more together. So let's do number 5. Yeah, 4 is D. All right, so let's do number 5 together. Water is flowing read, the units will help you. So go ahead and erase the board. We're on any problem here. Water is flowing at 8 cubic feet per minute. So what does that tell you? Volume. Very good. And it's a rate of change for volume. So how will I label that? Good. dV dt. And will it be positive or negative? It is flowing into a cylinder. So the cylinder is filling up. Pretend you're filling up a cup with water. So positive 8. The cylinder has a radius of 4 feet. The cylinder is not growing or shrinking, though. I'm not sure we're going to need that. Let's read the rest of it. How fast, or I guess we will need that. The radius is 4 feet. That's not changing, though, because the cup isn't growing or anything. How fast is the water level rising? So what is our question mark? Now, if it's the depth of the water, you would want to call that H. And why is that? Height. And when you go to your formula sheet, it's going to be on there as H. Will that be positive or negative? Yeah, positive, because the cup is filling up. All right. Now we have to pause at a certain moment. It says when the water is 2 feet high. So when the height is 2 feet. And again, I'm not bothering to put units on any of these because it's multiple choice anyway. All right. So go to your formula sheet. Which formula do you need? Yes, cylinder volume. So volume is pi r squared h. Now, I know I said last time, don't plug in until after you take a derivative, but the radius is constant. So you can go ahead and plug that in before you take a derivative. Are you envisioning, like, do you have an imagination? Envision like a cylinder and you're filling it up. The radius isn't changing. Do you know what I'm saying? Okay, so the radius you can go ahead and plug in. Radius is 4. 4 squared is 16. And then you can take a derivative. So let me amend that. You can plug in before doing a derivative as long as that number is constant. It just needs to be constant. All right, so what is our derivative? dV dt equals 16 pi, good. dH dt, perfect. And I don't think we're going to be missing anything here. I think this will be good. What is dV dt? 8. And then you would divide by 16 pi. So that would be 1 over 2 pi. So what letter is that? C, as in coconut. The 5 is C. There's a few 5s on there. So I'm going to be quiet and let you just use some time to work on this. If it turns out super nasty like that baseball one we were doing, please feel free to type it in the calculator, because you saw what happened when I tried to do it without a calculator and I just kept messing it up in my head. Don't do that. I don't know why I was trying to torture myself. If it gets really horrible, please use a calculator, okay?